Hello dear student, today we are going to discuss the exam style question of chapter 2. The first question is here. In this question it is given that 4 cars race along a given race track starting at the same time. The car that will reach the finishing line first is one with the largest maximum speed or acceleration or power or average speed. We know that average speed, we know that average speed will be equal to distance upon time, or we can write time t will be equal to distance upon average speed. Since distance is constant because all the cars move with the same distance, hence t will be least when average speed is highest. So for t will be least when average speed will be highest or largest. Okay, the correct option is answer B. The second question is here. A body is started from rest with constant acceleration in a straight line. After traveling a distance d, the speed of the car is v. What is the distance traveled when the speed of the car was v by? This is basically a question of straight line motion with constant acceleration. Okay, we can do this question by two methods, using kinematics as well as using energy approach or work energy theory. Let us start. Suppose the car is moving along this track. The car starts from rest, hence initial velocity of the car u is c. Let the acceleration of the car is a, which is constant, and after covering a distance t from here, the velocity of the car becomes c. First we calculate the acceleration in this case. Okay, so we can use the velocity displacement relation for the straight line motion. The relation is Vf final velocity square will be equal to ui initial velocity square plus 2 multiplied by acceleration multiplied by displacement. Okay, here final velocity is given as v, that is v square. On putting this value, initial velocity is given as 0 square plus 2a, and distance is given as t in the direction of velocity. From here we can calculate a becomes v square upon 2. Let this is equation first. Okay, now we want to calculate the distance covered by the car when its speed was v by 2. Suppose when its speed was v by 2, the distance covered by the car is d dash. Again, putting these values in this equation, we can write v by 2 square will be equal to initial speed 0 square plus 2. On putting the value of a from equation first, in this equation a square by 2d multiply by t dash. or we can write v square by 4 will be equal to v square into d dash divided by d. From here we can see that d dash will be equal to d by 4. Hence the correct answer is answer C, d by 4. This is basically first method using kinematics. Method first using kinematics. We can do this question by another method using work energy theorem. This is very simple method. Let us start this method. Work energy theorem. Work energy theorem. The work energy theorem states that work done by net force acting on a body W will be equal to change in its kinetic energy, that is delta K, or we can write it as K final minus K initial, or we can write it as half m v final square minus half m v initial square, where Vf and Vi are the final and initial speed and m is the mass of the body. Since the car is moving with constant acceleration, hence the net force acting on it will be a constant. Let the net force acting on the car be F. In first case, work done by this force in moving the car through a distance d, W1 will be written as F into d, or that will be equal to half m v square minus half m 0 square. Since velocity of the car becomes v after covering a distance d in the direction of force. Okay, or we can write Fd will be equal to half m v square. Let this is equation first. Okay. Again, it is given that the speed of car becomes v by 2. So we have to calculate the speed of car becomes v by 2 when we have to calculate the distance. In second case, work done by this force W2 will be equal to F into d dash. Here d dash is the distance covered by the car when its speed becomes v by 2. That will be equal to half m v by 2 square minus 0 on putting values in this equation. Okay, we simplify that f d dash will be equal to half m v square by 4. This is equation second. If we divide equation second by first, we see that d dash will be equal to d by 4. And the correct option is C. Now we have to go to next question. The next question is here. A sphere falls through a liquid and eventually reaches terminal speed. Which graph shows the variation with time of the distance traveled by the sphere? First we should know what is the meaning of terminal speed. Terminal speed is the speed or constant speed by which a body falls in a fluid or liquid. Since terminal speed Vt is a constant, implies that distance d will be equal to Vt multiplied by t. That is, distance at any time by the falling sphere in a liquid will be velocity or terminal speed of the sphere multiplied by time, which is a straight line passing through the origin. Hence, the correct option is option C. The next question is here. A steel ball of mass m is thrown vertically downward with initial speed u near the Earth's surface. The rate of change of momentum of the ball at its fall is. Let this is the ball having mass m. It is projected vertically or thrown vertically with velocity. Let the mass of the ball is m. Since according to Newton's second law, rate of change of momentum delta p upon delta t will be equal to net external force acting on the body or ball in this case. Okay. We see the only one force act on the ball, that is equal to weight of the ball or force of gravity m. Hence, rate of change of momentum delta p upon delta t will be equal to mg or weight of the ball. Thus, the correct option is answer D. Next, question number 5. A lunar model is descending vertically above the lunar surface. The speed of the module is decreasing, which is the free body diagram of the force on the landing module. Since speed of the module is decreasing, hence the net force or acceleration of the module will be opposite to the direction of motion of the module, or net force acting on the module will be in the vertical direction. From here we see that in option A, the net force is acting vertically upward. Since upward force is greater than the downward force in this case, hence in option A, net force will be upward, or we can say that its acceleration will be upward. If acceleration will be upward and velocity will be downward, so acceleration decreases the velocity or speed, hence the module will be descending with a decreasing speed. The correct option is option A. Okay, the correct option is option A. Now we have to go to the next question. Question number 6. A person of mass m standing on a weighing scale in an elevator. The elevator is accelerating upward with the acceleration A. The reaction force on the scale on the person is R. What is the reading on the scale? The reading of the scale R, reading of the scale will be reaction force. Reaction force on man, on person due to scale, or that will be equal to R, or that will be equal to mg plus m. Here we see that there are two forces acting on the person. One is its weight vertically downward mg. Second is reaction force R. Since elevator is going vertically upward with an acceleration A, hence net force on it, net force on the man will be in the upward direction, or we can write using Newton's second law, R minus mg will be equal to ma, or we can see that R will be equal to mg plus ma. Hence the net force on man is R, which is equal to the reading of the scale. The correct option is answer D. Next. The next question is question number 7. Here, a body of mass 3m at rest explodes into two pieces of mass capital M and capital 2m. What is the ratio of kinetic energy of m to that of 2m? Since initially the body is in the rest, hence initial momentum is of the body is 0 and net force on the body is 0. So we can apply the conservation of angular moment. Okay. Initial momentum of body will be initial momentum pi of the body will be equal to mass of the body 3m multiplied by its velocity, that is 0. The initial momentum is 0. Let after explosion the velocity of mass capital M is v1 and the velocity of mass capital 2m is v2. Then final momentum pf can be written as pf will be equal to m into v1. Here v1 is the velocity vector of mass m plus 2m into v. Since net external force on the body or system is 0, hence final momentum will be equal to initial momentum, that is pf will be equal to pi, or we can write implies that m of v1 plus twice m v2 will be equal to 0, or we can write or v2 will be equal to minus v1 by 2, or magnitude of v2 will be equal to half of magnitude of v2. v2 will be equal to half of v. The kinetic energy of the mass m km will be equal to half m v1 square, and the kinetic energy of mass 2m k2m will be equal to half into 2m into v2 square. On putting the value of v2, we can write kinetic energy becomes m v square upon 4 is equation second. Or we can write k2m divided by km will be equal to m v square upon 4 divided by m v square upon 2, or that becomes half. Implies that km will be equal to twice of k2m. Hence the correct answer is D. The kinetic speed of mass m will be equal to double of the kinetic energy of mass 2m. Answer D is that. Okay. The next question is given is question number 8. The power delivered by a car engine is a constant. Power is a constant. A car starts from rest. Initial speed of the car is 0. Resistance forces are negligible. Which graph shows the variation with the time of the speed of the car? Let us consider the mass of the car is capital M and power is P. that mass of car is capital, and speed of car and power of car is equal to P. Here it is given that P equal to constant. Let this constant is equal to C. Since initial speed of the car is 0, let after time t the speed of car becomes v. We can write kinetic energy of the car after time t will be equal to half m v square, where v is the speed of the car after time t. The power can be written as p will be equal to e k upon dt. That can be written as d by dt half m v square, or that can be written as mv dv by t, or that is a constant c. Or we can write v dv will be equal to c upon m. The conditions are given as at t equal to 0, v equal to c. That after time t equal to t, v becomes capital T. On integrating this equation within the proper limit given as, we see that integrating v dv equal to c by m dt. When t equal to 0, v was 0. At time t, the velocity becomes v, or implies that v square upon 2 having limit 0 to v will be equal to c upon m into t having limit 0 to t. On taking limits, we see that v square upon 2 will be equal to ct upon m, or v can be written as under root of twice c t divided by m. Or since c and m are constant, c is given constant, power is given as constant, and mass of the car is also constant, hence speed of the car v is directly proportional to the square root of the time t. Okay, therefore the graph will be a parabola symmetrical about the time axis, symmetrical about the velocity axis, because we can write v is equal to some constant k multiplied by t, and the correct option is shown in the graph A. Answer will be A. Answer will be A. The next question is question number 9. The diagram shows two identical containers X and Y that are connected by a thin tube of negligible volume. This is basically thin tube which have negligible volume. So the total volume of the water can be considered here. Initially, container X is filled with water of mass m up to a height h and y is m. The valve is then opened and both the containers contain equal quantities of water. The loss of gravitational potential energy of the water is, okay, let total mass of the water is small m. Initially, the total mass of the water can be considered at the center of container X, that is at height h by 2. At height h. Initial potential energy Ui of the water in container X will be equal to m into g into h by 2, or that is equal to mg h up. This is equation. When valve is opened, the water flows from container X to container Y due to pressure difference, and in equilibrium, the level of water in both the containers becomes same. The final level of water in both containers becomes at h by and h by. Here mass will be m by 2 here and m by 2 here, and this mass can be considered at the center point again, and this center point will be of height h by 4 in both the containers, h by 4. Then the final potential energy UF will be equal to potential energy of water in this container X and potential energy of water in this container Y. That can be written as m by 2, since mass of the water in container X is m by 2 into g multiplied by height. Height in this case becomes m by h by 4, plus similarly the mass of the water in container Y will be m by 2 multiplied by g multiplied by height. Height in Y also be h by 4. If we solve this expression, the final energy becomes mg h upon 4. This is equation 6. Hence, the loss in gravitational potential energy of water delta U will be equal to initial potential energy Ui minus final potential energy UF. That becomes mg h upon 2 minus mg h upon 4, or that comes out to be mg h upon 4. This is the loss in gravitational potential energy of water, and the correct option is given in option C. The correct answer will be answer C. Okay. Now we have go to the next question. The next question is the last question of this video or this chapter. In this question, question number 10, a person of mass m stand on the roller skates facing a wall. After pushing against the wall with a constant force F, he moves away, reaching speed v after a distance d. What is the work done by the force F? Since during the motion or during the displacement of the person, this force F act on the man. Hence, the value of F will be 0 when man or person is moving away from the wall. since this force F only acts at the time of contact with the wall. Hence the work done F W by this force F multiplied by D will be equal to 0, since F becomes 0 as person lose the contact by the wall from the wall. Okay, the correct option is answer A. The total question have been done. Keep watching this type of video. Please like and share our channel. Thank you for watching.